Hello everyone, welcome to this new video of Introduction to Fundamental Laws of Mechanics and Motion. So today we are going to explore the foundational principles that govern how everything around us moves from a simple ball to a celestial body. Let's move further. Today in this video we'll be covering these all contents, which is namely Newton's all three laws of motion and Newton's law of universal gravitation, law of transmissibility of forces, parallelogram of forces, and at last we'll see how these are connected with each other in real applications. So what is mechanics? Exactly what mechanics is. In physics, mechanics is a branch concerned with the physical bodies, their behavior when they are subjected to the forces or displacement, and the subsequent effects of those bodies on environment. Essentially, it's a science of motion and forces. You see mechanics in action everyday real life, whether it's car moving or someone working on an engine. So now let's move further and see the first law of mechanics, which is Newton's first law of motion. Now let's start. As this law can be also known as law of inertia, this law states that an object at rest stays at rest and unless and until it is acted upon an unbalanced force. Now think of example like a book is lying on the table. It stays there unless an external force comes and pushes it. Or imagine a hockey stick sliding across a ice, and this will slide across an ice unless and until a friction or another force makes it stop. This inheritance resistance to change in motion is what we call inertia. Newton's second law of motion is also called as law of acceleration. This law tells us that an acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The direction of the acceleration is always in the direction of net force. Mathematically, this can be expressed as F equals to ma. This is a very famous notation we all must be knowing in. F equals to net force and m is the mass of the body and acceleration. Now we can take it as example as consider pushing a small cart versus a heavy truck. You need much more force to accelerate the truck. Similarly, throwing a baseball requires a very less force than throwing a bowling ball to achieve the same acceleration. Newton's third law of motion. Finally, we can see this. This is an action or reaction law. This law states that every action has an equal and opposite reaction. A very common misconception about this is people think that both the forces are opposite so they will cancel out each other. But no, they won't cancel each other because they act on different objects. We can see some examples about it as walking. When we walk, your foot pushes the ground, which can be the action, and the ground pushes back your foot, which is the reaction, propelling you forward. For example, also in the rocket propulsion, the rocket expels the gas downwards, which is the action, and the gas pushes the rocket upwards, reaction. Also, a swimmer pushes the water backwards, and the water pushes the swimmer forward direction. Newton's law of gravitation. Beyond Newton's three laws, we also have Newton's law of universal gravitation. This fundamental law explains that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of distance between their centers. Mathematically, it can be stated as F equals to G into m1 m2 upon r square, where G is the gravitational constant, m1 and m2 are both masses of the objects, and r is the radius or distance between them. Now let's move to the law of transmissibility of forces. This principle states that the effect of an external force on rigid body is same. An external force is same regardless of where along its line of action or force is applied. For example, we can see imagine pushing a block from the front or pulling it from the back with the same force and along the same line. The block will move in the same way. Another example is rope tied to a post. Pulling the rope at any point along its length applies the same force to post. Parallelogram law of forces is a useful tool. It states that if two forces acting simultaneously on a particle can be represented in magnitude and direction by two adjacent sides of parallelogram, and then their resultant force. That's a single equivalent force and is represented in magnitude and direction by the diagonal of parallelogram passing through the common point. This law is used in various applications like calculating combined effect of two tugboats pulling a ship in different direction or analyzing forces on suspension bridges. It's important to see how these laws are interconnected to each other. Newton's laws from the bedrock of classical dynamics explains that how motion occurs and the gravitation is a specific type of force that perfectly obeys Newton's all laws and the law of transmissibility as well as parallelogram law, which are crucial tools for applying and analyzing the force system. Applying Newton's laws in complex scenarios. Together, these laws build the building blocks that help us to predict and understand the motion of the objects, from simple projectiles to intricate machinery. In conclusion, the fundamental laws of mechanics have vast real-world application. They are essential in engineering design, structures, vehicles and machines, also in sports science to improve and analyze athletic movements, astronomy for predicting the movements of celestial bodies, and ultimately these laws help us to understand why things move the way they do in our daily life. Thank you for watching. I hope this explanation has given you clearer understanding of fundamental laws of mechanics and motion.